stream just dropped. That's no good. See, YouTube. Is it working now? Still says I'm getting an error. Nope. Okay. Everything back on. Okay. What I want to do is make that large. Okay. I think everything is back live. Or is it not? Oh, it doesn't matter. Because no one's watching. Okay. Let's see if I could do something here. Stream error warning. Okay. Well, hopefully it gets better here in a second. Looks like it's really just gone bad. Okay. Looks like it's back up. Okay. Let's go to the stream here and go back to programming. Okay. So what does it not like about the reader interface? Here. Expected 2 arguments, found 3. Okay. Member function expected 1 argument, found 0. Oh, buffer. Yeah, we need a buffer for the reader. I forgot. Let's just do var buffer. You know, if we're gonna do this here, no. This is where I get. We hand the like we make a buffer here for the elf reader to do this, but okay, we're gonna do this. We'll just call it 2/8, and let's just make a constant. Say reader buffer size, even buffer size const was 4098. Buffer size undefined. Okay. Buffer. All right. What does it not like about my stuff now? Oh, it's never mutated. Silly me. Okay. Now, what does it not like about the interface? Here, IO reader is not a function. Ah. Okay, there we go. Okay, now what does it not like about seek? Okay. seek move. It's the how do you seek the file? Do I need to seek the file and then read? Is that how it is? I need to seek to repositions read write file offset relative to the beginning. Okay. What I need to do is reader that seek to let's just do this. Let's seek to do there, and then we do r dot read bytes all, I think, something like that. Read slice all. What do I not like about this? As usize. Error union is ignored. Okay, so if we can't seek to the file, let's take a look at this errors here that can happen. Seek error. If I remember right, yeah, you get end of stream, which means the fail, like read failed. In which case we got a position in the elf file that doesn't exist. That seems wrong and just fatal to us. So we're gonna just do fatal there. Catch error. And the other case is that there's a read error, which once again, I'm gonna say is fatal if we're not able to read it, the file. Kind of already had, like, we would have run into that up here. But let's do this. Catch error. Let's do fatal root error. Message, and we'll say reading.debug info. There we go. All right, so now we've got the bytes. Didn't need that. That should be, does it not like error union is ignored? Once again, here the error is if fills the buffer with next buffer length bytes from the stream advancing the seek position, invalidates previously returned. If the provided buffer cannot be filled, error end of stream. So once again, I'm going to say this. The bytes we already know should match. If they don't match, we're going to do this. If we're going to actually handle this differently. If I go to FE, does not know what type it does. Then we'll say basically we're going to do the same error here. And if we get .end of stream, we're going to do root.fatal message, and I'm going to actually do error dot invalid elf file. Say elf file is corrupted. Ooh, what is it not like here? Oh yeah, that's what it doesn't like. Okay, so then it doesn't like the error. Okay. Okay, so that's, yeah, we've got this function now. So all now we need, it doesn't like that we are returning an error here. A couple things. Parse doesn't take an Indian, so we need to add that in there. And we're gonna do that as, I think, types.Indian. Const types equals standard.build. There we go. And it's going to be bad because Indian doesn't actually get used. So let's just RA, nope. Apply fix all. There we go. Okay. So if we go back to dwarf here, it doesn't like that we're returning this because we're supposed to just return debug information. Parser has errors here. First of all, we need to change this error here to be debug invalid debug. Okay, so that wasn't even used anywhere. Okay, no. There, for now, we'll do that. Okay. Oh, the abrev tables need to be passed in too. Yeah. We need to parse the abbreviation table first. Okay, so that is good. Okay. He's thinking. Yeah, we need to read the abbreviation tables. In which case, do we just pass in the file, let the debug That I think that's actually smarter. So rather than passing in bytes to here, what we do is we pass in debug info, parse. I think we change it to read because then the parse can be a separate function inside there. We call read um, from elf. This is debug, yeah. Get info from elf. We're gonna read from elf and go to debug info, and we're gonna do hub fn read from elf, and this is going to return a debug info. This is going to take in an allocator mem.allocator, and we need in a file. We'll call that an io. No, fs.file, fs.file, and we need a elf data. We call this elf elf dot. Yeah. So we need to make sure we get those all imported in here. Const fs equals standard.fs. Then const elf equals import slash elf. Let's see. I don't know if that is. Oh yeah, elf.zig. Okay. And we do that here. Okay. Do FRA, GRA, fix all. Okay. Oh, no. There we go. That is better. I like that. Okay. Okay, now parse then is going to be different. Parse is, what does parse do? I mean, parse takes in bytes. I think what you do is you first build out the brief tables, and then you get the compile units. And the debug info is just the bytes that come in from there. So we don't need I think this what the parse does is just give you the compile units. Parse like yeah, parse debug info. And this just gives us compile units. Well, we'll come to that. We'll do that when we get there. Okay. So we get the read from elf. What we really want to do is pull in all of this first. Okay. There's a few things. Section names doesn't belong to this, so we need to do like dwarf dot section names, or we could just import it and see. Const section names equals at import. Slash dwarf Zig section names. Declarations are not all allowed between container fields. Oh, did I make a declaration? What? I don't understand where the declaration is being made. I mean, I get this is a declaration, but is there? Let's see. Nope, field declared here. Field after declared here. Oh, okay. That's not a great error. Okay. Okay. FD, yeah. WX, there we go. Okay, so section names there, root fatal. So yeah, we do need to just, I would like to just return these as errors. Um, error, no debug info. Let's get this an error set. Okay, error equals, or let's call it const debug info error. Oh, let's just call it error. Error. Oh, I already have an error here, but you know what? We'll get rid of that. Okay. So then this returns error. Okay. Or else error, no debug info. Okay. Indian types, Indian switch, elf, header data. Okay, here we're gonna do another. We need to make that error. There. Get another fatal. So what we want to do is instead of catching the error here, we're going to try we'll add allocator here. That's yep. Okay. And let's see, keeping going. Buffer size. Yeah. Add that here. Const 10 40 96. Sectitian names is not a, yeah, that's not correct. Section. Okay. Yeah, there's no root. So yeah. Maybe this is a case where we do have the fatal in here. Maybe we're gonna do all the stuff we just did. Just fatal. Because this is all happening at the beginning, right? As we're loading the target, reading in the debug information. So why not just fatal here? Why pop all these things up? So let's do that. Oh no, you need to we'll do this root equals at import main.zig. Yeah. Okay. Oop. Okay. Unused local constant. We will use that. Don't worry. We will use it at some point. Enable load. File not found. Is dwarf.zig not a file? Is it not? It is. There we go. Okay, I've committed all that stuff. Ugh, okay. So we decided this was called dwarf. Dwarf dot debug info read from elf allocator file and elf data. Return. Doesn't like this. Buffer size doesn't exist. I should make that. No. Okay. Still doesn't like this is unused. So for now, let's just apply a fix all. What do you call this? Root source file dwarf has no member section names. It does too. Oh, there we go. Debug info is not marked pub. I think that this probably deserves to live in anything not in the dwarf parent file. So let's move that because really everything about debug info is being parsed here. For rather than function with non-void type debug info returns implicitly. Okay, so once again, we're kind of back to where we were. But now we can start building out our return. Compile units equals compile units dot brev tables equals brev tables and dot what is it debug info equals debug. Actually, I think we call it bytes here. One of those is the correct thing. Okay. Now it's just mad that we don't have compile units here. It's fine. I expected that. I'm sorry, guys. Okay. So now let's review where we are at. First of all, I do want to go to main. And okay, so there are things in main. Did they not get committed? I thought I'd been committing things. Oh my goodness. I mean, I want to see what the apparently I haven't committed any of these things. Okay. Um, let's see, what call it feet. Add new fatal error messaging. Handle errors. Golly, okay. Now I got that out of the way. This isn't ready to be committed yet. So I think this function, we're just keeping this. I'm gonna add a little note here. This function does way too much. Yeah. Note. This function is now defunct. It should be kept only until we get line number info stored into the debug info system. Okay. So this is just for reference. This is just for reference. Yeah. Okay. So okay. Okay. So let's get we need to get the compile units, but actually before we could do a brev tables or compile units, we need to do brev tables. Okay. This is all for compile units. I don't know if we need Indian size for abbreviation tables. Oops. This is where we look in the docs for this again. Where is... Ooh. Okay. Unit headers. Type unit headers. Abbreviation tables. So the abbreviation tables for all compilation units are contained in a separate object file section called debugger. We know that. As mentioned before, multiple compilation units may share the same abbreviation table. The abbreviation table for a single compilation unit consists of a series of abbreviation declarations. Each declaration specifies the tag and attributes for a particular form of debugging information entry. Each declaration begins with an unsigned Little Indian binary 128 or Little Indian base 128 number representing the abbreviation code itself. It is this code that appears at the section of debugging information. Let's do this. Make work smaller. This is easier to see for everyone who's following along. Okay. So then we've got, let's see, 4 8-byte unsigned off abbreviation tables. Here we are. The encoding for the tag name. Following the tag encoding. Codings of the child determination byte given here. By the child encoding. I know how question is here. The debug abbrev offset is a 4 or 8-byte unsigned offset into the abbrev section. This offset associates the type unit with particular sort of debugging information entry abbreviations. So we kind of need to read the header first. Get this information. Okay. Get the debug info header for every compile unit. Read its abbreviation table and then parse it out. Is that what I'm seeing? If that's the case, then a little mistaken. This will still work out fine, but what we'll want is still need Indian because we need to know what the format of this is. But what we'll want to do is actually go to PAL units. Yeah, so we'll just need to read the dwarf header or the unit header. We can do right here. We get the bytes. We'll call this debug info. Um, so what we gotta do is parse the debug info. Here. Let's see. Trying to find where's the right spot. Oh, let's put those together there so they don't get separated. Buffer, reader, read, seek to. So we're seeking to the beginning of the offset. So this is all. Then we seek and we read. Seek to it, read it, catch the error there. Okay, so we have the debug info now. Is full const. What we gotta do is read the header. So compile unit. So actually what we gotta do is we could just go for compile, yeah. We can read all the compile units. Let's do this first. Equals var compile units, and we're gonna call it okay. And kind of want to like alias this. Maybe something like cu unit, like yeah, unit map, compile unit map. Const. Yeah. So let's say we could do this. Okay. So now we just need to read all the compile units. So we've gone to the beginning of the debug info section. We're going to read the first part, the header of every, we're going to parse the header out. That's the problem. Yeah. Because I want to name a math based off of the thing, but you don't get, you get a unit length, version, unit type. That's the problem. Okay. Now I'm getting it. So each compile unit begins with a debugging unit information entry. I think that's written here. Each debugging information entry begins with an unsigned number, but no, this one begins, it says, here it is. For each type defined, let's see, for each compilation unit within a dwarf producer, a contribution is made to the debug info section in the object file. Each such contribution consists of a compilation unit header followed by a single dwarf tag compile unit or dwarf tag partial unit debugging information entry together with its children. For each type defined in the compilation unit, a separate contribution may be made to the debug info section of the object file. Each such contribution consists type. Okay. That's not, but what is interesting is that when we look at the compilation unit headers, right here, we get unit length, a version, a type, the address size. So that's if it's a 64-bit or 32-bit version of, oh no, that doesn't have anything to do with that. That's decided up here. The debug abbreviation offset. That's the offset to the debug abbrev table where you can find its debug abbreviations. So that has to be parsed before we can actually put the compile units into the map. So what we got to do is for every compile unit, we've got to then also have the brev tables. And I'm gonna alias this to const brev table map. It's that. Go. And so we're gonna have to build out this brev table map here. Car brev table brev table map. Okay. It doesn't like that I made them var. Well, it's gonna have to deal with that. Yeah. Because they will be var here soon. So what we need to do then is let's just do this for the first one, and then we'll figure out how to loop it. Do it for every compile unit in the debug info section. So I believe we could just actually do that. Let's just do this compile unit. So starting with this, let's cu equals const compile unit, which is a file unit or unit header cu.rc.parse. Yes, and that's where Indian comes in. And hey, look, we give it a reader. Not ideal. No, we want to just give it bytes. Taking bytes and parse. Yeah, I want to give it the bytes. source bytes. Debug info. Well, we could give it a reader. We could do debug info. We could do io.er. Fixed reader, I think is what it is. And do endian. Then I have IO imported. Okay. Const IO equals standard.io. Unused local constant. Yep. I guess that's io dot reader dot fixed. That's what it is. But we need to assert that reader is greater than 64 bytes. How many bytes the debug info is, right? So the debug info header has to be 4 or 12 bytes. So let's do 12 plus 2 plus 1 plus 1 plus 8. Oh, that's right. They're different sizes. Oh, man. I just don't like doing the fixed because I'm not sure if that's actually going to work. Like, we do the fixed. Figure out this. Read slice all. I mean, I think this is fine. It's just, we got to think about this. Can I guarantee that debug info is actually going to be enough? I guess we can get read failed, read into stream. If it fails, then yeah, that's it. It fails, and we can handle that. Okay. So we can catch. Really, you just I think it's fatal. Like, right? We're reading the header, giving it debug information. That debug information isn't big enough to contain the header of a unit, a compile unit, or doesn't contain a compile unit, then this is what I want. Parse. Like, yeah. Okay. Now that we have the compile unit, cu dot we want is size. Let's see, while do size equals 0, size let's see, offset. What is the offset? Const, see, offset. Var offset usize. Well, offset to say, I mean, it's just while true, but I hate that. While offset, because we just want to keep reading until we get to an offset that's greater than the length of the debug info section. Yeah, so while offset is less than, because the last offset will give us a size. The last debug will give us a size. And so while offset is less than lang, let's see, debug info dot lang. Go, instead of do debug info, we do debug info offset. And then we do cu size, we do. Now what we have to do is remember that we have to offset it by this. So let's do like, let's add a function here to the unit header, which will just give us the offset. We're just gonna add a function, call it pub fn next offset or next unit. Gives the location. Nope. Should we call it next offset? Offset gives the offset set to the next compile unit header or end of the debug info section. All right, I gotta wrap it up. It's time to go eat lunch or dinner. So it has been great streaming. Thanks for watching. I will see y'all